Sophisticated electronics are now flying and navigating the Challenger. Any changes in course or altitude are now made with small controls on the glare shield.
We have here 3 knobs, one to select the heading we require, or the course we care to follow, or the airspeed we would use in climb or descent. On the other side, the co-pilot has the same heading selection for his sides, his course selection, but he also can select the altitude that we are descending, climbing to, or cruising at, as is displayed here.
One of the things which is tremendously impressive, if you go into the cockpit of one of the more expensive business jets, one of the long-range ones, is that they have a suite of navigation equipment which puts a Boeing 747-400 to shame. They really do want to be able to go absolutely anywhere, to small airfields which are close to the place that they want to go to, which is what they buy a business jet for, the ultimate inconvenience.
The instruments you see here in the cathode ray tubes represent really what is the cutting edge of technology and flight instrumentation. In this airplane, really the only ones we're missing is to have our engine instruments displayed on cathode ray tubes. In the next vintage of Challenger, that will be accomplished. The flight management system incorporated with the instruments that I've talked about in front of us is a Honeywell flight management system. And in this system, we can follow our fuel flow, follow our full trip. We can schedule trips of any length in here, providing the airplane has the capability of making it. It has a database to cover the world for accomplishment of most navigational facilities and airports which have an instrument approach and 4,000 feet of runway. To accomplish its ability to navigate, it's powered by 2 inertial nav units. It has a global positioning system incorporated in that, and it also takes, when within range, information from visual VHF Omni ranges. They cross-reference this and come up with the most desired position, which has an accuracy that I'm not sure I know, but it's unbelievably correct.
The accuracy of inertial navigation units depends on Isaac Newton's first law of motion and a familiar childhood toy, the gyroscope. A spinning gyroscope has the unique property of being able to hold its position in space. 3 gyroscopes can be coupled together to form a stable inert platform. Any movement can be measured and a new position calculated. But now the spinning gyros have made way for a new inertial device, the laser gyro. In these systems, 2 laser beams travel in opposite directions around a triangular path, bouncing off mirrors at 2 corners. As long as the laser gyro remains at rest or in steady uniform motion, the wavelength of both laser beams remains the same. But when a force is applied, things change. When the laser gyro platform is turned, there's a frequency shift in the laser beams. That's measured and computed by the flight management system to amend the aircraft's position. Every laser gyro inertial system is put through a series of calibrated turning tests before installation. Their accuracy has made navigating, especially over wilderness and oceans, much easier.
When you're flying over non-navigational areas such as the ocean, with the incorporation of the inertial nav units and the the global proximity positioning system, we rely completely on those 3 systems to give us our navigational information to head to the desired points outside the range of a normal radio facility. New York to London is a fairly standard for this airplane, as is places like Toronto to London. Further into the interior, Montreal to Vienna is a very likable leg for this type of airplane.
As we approach Britain from the Atlantic, the distinctive shape of Land's End and Cornwall shows up on the Challenger's radar. The colours show the strength of the radar echo. The more purple the colour, the stronger the reflection of the Challenger's radar beams. With the Cornish coast itself in sight, the aircraft is put on a new heading for its destination, Farnborough. The Challenger, designated November 602 Charlie Charlie, is going to make a PAR, a precision approach radar, in which it will be torqued down all the way to the runway.
November 602 Charlie Charlie, as you turn onto 350, there will be traffic to the north of you 5 miles, not above 1,400 feet on the QNH, 500 feet below. This is positioning for PAR approach, runway 07 at Farnborough, with a 3.5 degree glide path. Procedure minimum based on QFE is 270, touchdown elevation is 229 feet.
202 Charlie Charlie.
And 22 Charlie Charlie, will you be landing or overshooting from this approach?
We'll be landing from this approach, and it'll be a full stop.
Number 2 Charlie Charlie, roger.
The Challenger has TCAS, a traffic collision avoidance system to warn the crew if other aircraft get too close. A helicopter is heading towards them.
Farnborough Navy 544, steering to the west, just wide of mark.
We're going to do a precision radar approach to runway 07 at Farnborough.
Farnborough Navy 544.
Our reference speed is 129 on final. We're currently on a commanded heading of 350.
November 2 Charlie Charlie, the 1,400 foot traffic is in at 2 o'clock, 3 miles. We'll be turning back northbound, maintaining 500 feet below a Puma.
202 Charlie Charlie. I don't have visually, but I do have on TCAS.
Roger.
And I do see him now. I have him visually.
Thank you very much.
Roger, Walter.
Roger.
I don't have him.
Got him?
No, I don't. It's okay.
About 2 o'clock low. It's a helicopter.
Okay.
No crash.
602 Charlie Charlie, turn right heading 060 degrees, closing final approach track from the right, 7.5 miles.
060 2 Charlie Charlie.
And 2 Charlie Charlie, report checks complete to land.
Charlie Charlie, that's forwarded.
Thank you.
Traffic is now what
60 Charlie Charlie. Talk down, have you identified 7 miles from touchdown, contact talk down on 130.05, the right.
30.0.
130.05.
05.
He's right underneath us.
That's
Okay,
right.
I got
That's
him.
the helicopter. That's the TCAS alert that we got.
I got him.
Farnborough November 602 Charlie Charlie is with you.
602 Charlie Charlie, roger. Right descent line correcting. 6 miles from touchdown. How do you hear?
Charlie Charlie.
Flaps 30.
Continue heading 060, 1 mile to the glide path. Hello, height, no need technology further transmissions. Check your gear is down and locked. 5.25 miles from
Landing gear
touchdown.
down.
Begin descent now. 3.5 degree glide path. On the glide path, slightly right to center line. 5 miles from touchdown.
Flap 45.
Turn right 5, heading 065. 4.5 miles from touchdown. On the glide path, slightly right to center line.
03 Charlie Charlie, the wheels are down.
Roger, nicely on the glide path, slightly right to center line, correcting slow. 4 miles from touchdown. On the glide path, very slightly right to center line, continue the approach, 1 ahead to roll. On the glide path, right 3, heading 068, 068 to heading, on the center line, 3.5 miles from touchdown. Right to number 2, 070, drifting slightly left to center line, 070 on the glide path, slightly left to center line, 3 miles. You clear to land from this approach, the wind 110 at 6 knots. On the glide path, slightly left to center line now, turn right 3073, 073 to heading 2.5 miles on the glide path.
Gears down, flaps are full, pressures are checked, you're clear to land.
Going slightly below the glide path, adjust right to descent, 2.25 miles, 073 to heading, slightly left to center line. 2 miles, back on the glide path, adjust right to descent, slightly left to center line, correcting slow. 1.75 miles, slightly left to center line, nicely on the glide path. 073 the heading, 1.5 miles, approaching decision height, going slightly below the glide path, adjust right to descent. Still slightly left to center line, 1.25 miles. Turn right to 075. Still
The Challenger's artificial voice joins in to alert the crew they're getting close to the ground.
Minimums.
Slightly below the glide path now. Slightly left to centre line, correcting slow. Passing to his right, slightly below the glide path, slightly left to centre line. Still slightly below the glide path, slightly left to centre line. Over the end of the runway, slightly left to centre line, slightly below the glide path.
Right aileron is used on touchdown to counter the crosswind.
Slightly left to centre line, radar touchdown now. Approach complete, talk down out.
Business jets are every bit as safe and fast as commercial airliners, but they are expensive to own and operate. Now, though, more corporate customers are following the example of those private pilots with whom they share the airstrips. They're pooling together to buy aircraft and operate them on a group basis. That's an arrangement which is now creating even more demand for business jets, something the Challenger and the rest of the business jet industry can waggle its wings about. Next this evening, the spectacular photography of untamed Africa as the animal young develop their skills for survival.